Hello and welcome to the session. In this session, we'll discuss three problems related to z-test. So this is the first problem. A researcher believes that the average height of adult women in a city is greater than 5 feet 4 inches or 64 inches. A random sample of 100 women from the city has a mean height of 64.5 inches with known population standard deviation of 2 inches. Test at 5% significance level. So when you're given any z-test in the examination, these are the 5 steps that you need to do. First step, you state the null hypothesis H naught. Now this null hypothesis H naught colon mu is equal to 64. You have to find the mean. As we know, z-test is basically we are doing a comparison of the mean value, right? So the mean value mu here is 64 inches, which is basically the population mean, which is given in the question. The second step is alternative hypothesis H1, where I am saying that H1 alternative hypothesis states that mu is greater than 64. Now why greater than 64 is because when the random sampling was done, the mean height I got 64.5, more than this. Now you have to calculate the Z statistics. So before you calculate the Z statistics, first you have to decide whether this is a one-tail test or a two-tail test, because for a one-tail test this is a formula for calculating z value. Z is equal to x bar minus mu divided by sigma by root n. For two-tail test it's a different problem. Okay, now this is a definitely a one-tail test because main thing is I am doing comparison of only one population. I just have one population where I am saying that there is 100 women where I have the mean height of 64.5. So I am not having two different populations, right? So therefore this is a one-tail test. So for a one-tail test, the Z calculation is like this. So what is the X bar? X bar is nothing but 64.5, which is the mean I am getting from the samples. Okay. Mu is nothing but the population mean. The population mean I got was 64. Divided by 2. 2 is the sigma value which is given as 2 in the problem here. Standard deviation. Divided by root of 100, where 100 is nothing but the number of size of the sample. The size of the sample is 100. So I am getting a value of minus 2.5. Now in the fourth step, you have to determine the critical value. So for this, in order to find the critical value, you should refer the table of Z table. You should refer the Z table. So that should be given for you in the examination. If it is not given, right, then you assume the significance levels of 5%. If it is not, even if significance level is not given in the question, you assume it. 5% significance level or 0.05 significance level should have a critical value of 1.645. Or if it's given in the exam, this is the Z table, right? So for the significance value of 0.05 here, the Z score is 1.6 plus this 0.0495. Okay, so this is a Z score. So for a significance level of 0.05, the Z score is 1.6 plus this one, that is 0.0495. So you can take it as 1.64, that's enough. So with the 1.64, you take the critical value. 1.645 is the critical value. So in the fifth step, you compare the values which you got from step 3 and step 4. That is, you compare the Z statistic value with the critical value. So here mod you have to take, because this is a negative value. Mod of minus 2.5 is greater than 1.645. Therefore, since it is greater, right, we are rejecting the null hypothesis. If we are rejecting the null hypothesis, it means that the alternative hypothesis is true. Therefore, you have to write this conclusion that therefore evidence shows that the claim is supported, and therefore the average height of women is actually greater than 5 feet 4 inches. This is true. So this is a conclusion. Now coming to the next question. Let 12 be the population mean with population variance of 2. Consider the sample x is equal to 1, 2, 3, 4, 5. Apply the z-test and show whether the result is significant. Now in this question, they have not given you the mean value. Okay, you need to calculate looking at the sample. That is one extra step that you have as compared to the previous problem. Otherwise, all the other things are same. So first step, find the mean of x. Mean of x is just add up everything, divide by number of samples. I am getting the mean value as 3. Right? So this is the sample mean. Now next step is you have to take the null hypothesis. So null hypothesis, I am saying H naught is mu is equal to 2. Alternative hypothesis, I am saying mu is greater than 2. Why am I saying mu is greater than 2 is because they are saying the population mean is 12. Okay, so therefore it is greater. It is greater as compared to the mean that we got from this sample. The population mean is greater than the sample mean. That's why I'm writing the alternative hypothesis as mu is greater than 2. Now, next step, set the significance level. Now, significance level, since they have not given here, in the previous question, the significance level was given as 5% or 0.05. Significance level is nothing but the alpha value. Both are same. Okay, so you set, if suppose they don't give in the question, you assume the alpha value or the significance level as 0.05. Now again same step, you determine the critical value. See, the steps are same as compared to the previous problem. Okay, only thing is now I am assuming the significance level since it's not given in the question. So you find the critical value for this significance level of 0.05. Just like we did in the previous problem, go to the table and cross verify. For a one-tailed test, it will be a different table. For a two-tailed test, it's a different table. Since now this is a one-tailed problem, you remember this value. Suppose they don't give the table, so remember this. For a significance level of 0.05 in a one-tailed test, the critical value is 1.645. And for a two-tailed test, the critical value is 1.96. Just remember this. Now you calculate the Z statistics. The formula remains the same, x bar minus mu divided by sigma by root n. What is x bar? It is the sample mean, which is 3. What is mu? It is a population mean, that is 12. Divided by 2 is a standard deviation, divided by root 5. N is a number of size of the sample x. So you get the value as minus 10.11. Now you compare the critical value with the Z statistics. So mod of 10.11 is much greater than 1.645 or the critical value, right? It's much greater than 1.645. Since it is greater, we reject the null hypothesis. That's all. That is a conclusion. Now coming to the next problem, this is a two-tailed problem. That means we are having two populations that we need to consider. When I say two-tailed test, that means I am comparing the mean value of two different populations. See, there are two different types of fertilizers which are tested in the crops. First fertilizer, call it as A. It yields a mean value of 50 bushels per acre with standard deviation of 5 bushels. Second fertilizer B yields mean value of 52 bushels per acre with standard deviation of 6 bushels. Now determine if there is a significant difference in the mean yield between the two fertilizers at 10% significance level. So they have given the significance level, that is alpha here. And the sample size is 100 for A and B. So N value is 100. The steps remains the same. Null hypothesis, H naught. Since I am comparing two different populations, I am taking mu of A, that is mean of fertilizer A, is equal to mean of fertilizer B. That is a null hypothesis. Alternative hypothesis, I'm just going to say, since there is no comparison here in the question, they are not saying that the mean value should be greater or lesser. So that means alternative hypothesis states that mu A is not equal to mu B. So that means what? Mu A can be greater than mu B or it can be less than mu B. So there are two options and therefore definitely this is a two-tailed test. Now the rejection area can be on the left or on the right. Now third step, calculate the Z statistics. So for this it's a different formula. If you have a two-tailed test, the formula is Z is equal to XA bar minus XB bar divided by sigma 1 by root N1 plus sigma 2 divided by root N2. XA bar is the mean of the fertilizer A, which is 50. XB bar is mean of the fertilizer B, which is 52. And sigma 1 is, sigma 1 for fertilizer A is 5, sigma 2 for fertilizer B is 6. And the sample size is 100 for both. N1 and N2 both are 100. So I am getting Z value as minus 2.5. Now determine the critical value. So for a two-tailed test, this is a two-tailed test. At 10% significance level, the critical value is 1.645. You have to refer a different table, Z table for this. So for 0.01 significance level, the critical value is 1.645. Now compare the Z third step with fourth step. Right? You compare the Z statistics to critical value. So from that you can say mod of minus 2.5 is greater than 1.645. So therefore, we are rejecting the null hypothesis. So what is the conclusion? The evidence suggests that there is a significant difference in the mean yield between the two fertilizers. So the evidence is proving that alternative hypothesis is true, and there is a significant difference between the mean yield of both the fertilizers. So that's the conclusion. So that was it. So in this session we have discussed about 3 problems of Z test. Please, if there is any doubt, please write to me in the comment box, and please subscribe to the channel, and please like, share the video with your friends. Thank you so much.